Hey guys, morning. Decided to wing another one here. Pulled up the latest space ISWA space weather run. There's the Z-cut looking straight down on the Earth. These arrows indicate solar wind. They always should be coming from right to left because there's the sun side of the Earth. But as you can see, they're getting all scrambled in here. All this blue stuff is plasma. It's high energy electrons, which the Earth is continuously trying to expel from by having to develop sort of a backside bow shock. So we got the front side bow shock to ward off the solar wind coming from the sun. And see these lines here? That would sort of like indicate a backside bow shock, but it's not round and symmetrical like the one in the front on the sun side. However, this shows you that there's some extra parts of our magnetosphere, which can be represented here by the red closed field lines that are balling up behind the Earth to try to ward off all this backside pressure coming from, well, it has to be Nemesis, which is our binary twin sun, that emits mostly electrons. If you watch any of Astral Traveler's earlier videos, when he was still putting stuff out about Planet X or the low energy field object, low energy electron object, pretty much documents it's emitting mostly electrons, and our sun emits mostly protons, which in the equal opposites law Newton put together way back when pretty much makes sense if you think about it. These are the blue interplanetary magnetic field lines. They indicate connections between the Earth and the Sun, along with all the other 9 planets. But as you can see, we have way more than 9 blue interplanetary magnetic field connections going on. So that's just a further indication of a second solar body out here that's connecting to all of our 9 planets. And supposedly the Nemesis system has 7 planets, which 9 plus 7 makes 16 times 2 suns. That's like 32 interplanetary magnetic field connections, which wouldn't be too hard to imagine that would be the case, judging by all the ones you see on here. The black ones, they're the polar cap field lines. Normally they just stream away from the Earth, away from the sun side of the Earth, and it directs all the solar wind from the sun away from the planet. Whenever the solar wind gets strong, that's when they become closed, and that's when we get our auroras. That's why they're called polar cap field lines, because they reconnect at the poles. So as you can see, we get almost constant, pretty much constant connection now. So I imagine the auroras are pretty vivid, although I haven't seen a lot of mention of it lately. And but then you see these black field lines balling up back here and closing to ward off all this pressure. But the real reason I wanted to, and these two are synced, the Folk radiation belts, this is at the lowest energy electron level, the ones that are moving the slowest, and recorded at the lowest reading, which is 10 keV, and these are the high energy electrons, the ones that are moving the fastest. So they're really zipping around, and they're recorded at 4,000 keV or 4 MeV. Now last night I showed you that Mauna Loa Solar Observatory run, which corresponded to a huge energy splash that we had around midnight on the 13th, when all this red splashed in and even got close to the Earth, well within the geosynchronous orbit here where the satellites go around. These, like for instance, these GOES 13 and 14 and this Korean satellite represented here. That's the geosynchronous orbit of 22,236 miles above the Earth. And it's pretty easy to maintain, so it's just a constant orbit. And these are the satellites that are giving us these simulations. So all this space weather is coming from inside the magnetopods. So real quick, let me show you, if you look at the video yesterday, here was my the run for 14. Sorry about that. This is yesterday's video when I was showing you the big flash and the splash, but I'm not going to show you that again. You can go back and look. And this is the one for yesterday that I was showing you that had the look at those things zipping through. I mean, that's pretty close to the Earth, and they're pretty big. So this thing's playing through at a 4-minute. Every 4 minutes we get a screenshot. So you figure these things lasted for like about 8 minutes, and they flashed through. But my point is you wouldn't see it again on today's run. And well, let's just look at this real quick. So you see how those things go flying through. This was yesterday's run, the 14th. It's not going to show it. Where was it? Where was it at? Okay, here. I'm going to stop it. So you see, because I want to make a point when I show you the sanitized run. Remember these circles that usually show up? These magnetic concentric circles, which represent, in my opinion, probably some of the planets in the Nemesis system. Okay, they don't show up on here before they sanitize it, but look at the sanitized version. This is for yesterday. Okay, first of all, you can see they took out those huge, big, close things that flash through. But now these circles start to show up more. So here's what I'm thinking. Somehow, well, most of those flashing things that go through the circles, which I submit debris field from Nemesis, they're happening fairly close to the planet. And you see these circles here I'm talking about with the concentric rings, magnetic signatures. So I think, since this is done in gamma, it picks up magnetic signatures. There's another one there. They're all over. You can see them pretty good after they sanitize the video. And here's what I think they're doing. They're somehow able to take off the lower layer of the stuff that's close to the Earth and just like remove it like an MRI cut plane. Just whoosh, take off that slice, but the stuff that's behind there is still showing up, and you can see we still have some debris field running through and all that. But they took off the, well, however many layers that were closest to the planet, enough to get rid of. And you see what I'm talking about? See how it's a lot more staticky, and you can't see these circles? This is on yesterday's unsanitized version. And then there you have it. So that's the unsanitized version. There's those things flashing through. Okay, well, point taken. Here's what I'm talking about with these cut planes. See how this is just another representation. This is from University of Michigan. geospace model, and they put it up on a government website. And I'll leave you the link below. Anyway, this indicates pressure. So what we're looking at here is the equatorial plane. That would be the Y cut. This cut here on the ISWA thing, they got the Earth and the Earth flipped around. Sun side's on the right here, and on theirs it's on the left. So what they do is they take like a slice through the magnetosphere, like sort of like an MRI slice. It's a cut plane. So we're looking at the Earth from a sideward position. So this would be the magnetosphere, how it would appear if you were looking at it from the side. It's just like a slice through the middle of it, probably like the middle right near the Earth. And you can see we got all the backside pressure showing up here. And then you have the Z cut, which see how the sun side's different. It's flipped on this. This is the north-south meridian plane, which is the Z cut. That's the one we see on ISWA here, showing you the solar wind. One other thing I wanted to show you, this is the Discover satellite. This is the one that they put up to replace the ACE satellite. Went up in 2016, and it's up the same spot, L1 Lagrange point. And it measures, this measures all this data coming from the sun. So this is like, it's not the scale. This would be the L1 Lagrange point. It's a fixed orbital position. This is where the Discover and the ACE satellite are parked. And these are the readings we're getting 930,000 miles from the Earth. So it's like an early warning satellite, more or less, they put up to give us advanced alert of anything coming from the sun within 15 to 60 minutes is what I read. So here we go, here it is, and this one's cool, better than the ACE. For one thing, you get less of a gap, which I think somehow related to maybe battery recharging or whatever. That's the only thing I can figure. And this gap's only about 2 hours, whereas the ACE gap's 8 hours. So what I showed you yesterday in that other vid where we had some other half-hour gaps, which might indicate some I'm thinking planets or large pieces of debris that are interrupting the data collection on the Discover satellite, because then it picked right back up. And this is, I pulled up today, and I've never really seen the solar wind. Here's the solar wind speed. You can see the times up here. Of course, the times down here too. But as I drag it along, you can see the numbers. Those are giving you numbers for solar wind speed. Look how, and look at the graph, the purple graph, how up and down it is. Now that would suggest to me that there definitely are some planets or a debris field or something that's interrupting the data collection on the ACE satellite. That's why we're getting such sporadic solar wind speed readings. And as you can see, it's starting to come up just 12 UTC, which is about 5 a.m. Eastern Daylight Time. It's getting pretty high, up to 6:05, and came back down a little bit. So I don't know, we'll have to keep an eye on that. And then watch the phi angle. Anything above 180, these are degrees here on the left. Anything above 180 indicates a connection to something behind the Earth, a solar body behind the Earth. And you can see just about everything's above 180, except for this little bit here where the Earth tried to connect back to our sun. So I'm running out of time. I can't believe I put 15 minutes in this thing already. Hope you're still with me and listening, and check out the video yesterday on the MLSO energy splash, which showed up here at exactly the same time, a huge splash of red. This solar wind speed, it's being measured by these geosynchronous orbiting GOES satellites. So this is all stuff inside the magnetopause, basically. Anyway, I'm running out of time. God bless, peace, and I'm out.